Hello everyone, welcome back to another video for the series. I'm Hugh and today I brought a problem from Baltic way. I never heard of this competition before, I'm sorry, but I just found this really great problem from the internet, so I wanted to share it with everyone. So when I first tried this problem, I was not able to solve it, but after looking at the official solution, I realized that uh, it is quite reasonable, and the thought process is quite, um, yes, quite reasonable. And I want to share the thought process that was involved in the official solution in this video. So that's why I'm making this video. So before we start, we know that a sub n equals this, and this is a recursive formula. And also we have square root here, and we have square here, and we have fraction here. That means, what if we can write a sub n like squared, but we want to reciprocate it because we want to find the reciprocal of it because we have a potential fraction here. So we have 1 over equals times a sub m minus 1 squared all over a sub m minus 1 squared, and this is equal to 1 over a sub m minus 1 squared plus 2020. And I think we should really be thankful that this is a recursive formula because we know that 1 over a sub n squared, therefore minus 1 over a sub m minus 1 squared is simply equal to 2020, which means we can telescope the sums. So we have, what am I doing? Over, so minus squared plus 1 over a sub plus plus 1 over a sub 1 squared minus 1 over a sub 0. Oh, why is it going up? 1 over a sub 1 squared minus 1 over a sub 0 squared is equal to, wait, how many, this is 2020, this is 2020, 1, 2, and then we should have 2020, so times 2020, and when we telescope them, we have, these all cancels, so minus is equal to 2020 squared. Now notice that because a sub 0 is greater than 0 and is a real number, we know that is greater than which is 2020 squared. And notice that this should be true. Yes, this is always true because a sub 0 is greater than 0, obviously I think a sub 1 should be greater than 0 because positive and positive. If a sub because a sub 1 is greater than 0, a sub 2 will be greater than 0 with the same reasoning, and by induction we have a sub 2020 also greater than or equal to greater than 0. That means it can never be equal to 0 because our numerator is actually, what if our numerator is 0? We can't, because when a sub 1 has a sub 0 for our numerator in this form, and that's not equal to 0, that means a sub 2 not equal to 0, and by induction a sub 2020 is always greater than 0. That means this always works. This is true, always. By induction, I think, although is this not necessary, I think it's just quite like good to include this as our side note. So we have squared greater than 2020 squared. Therefore, we have multiply, so, and divide. And because we know that a sub 2020 is greater than 0, we know that, yes, is less than 1 over 2020. And that's the same thing that we have, and that completes our solution. So I think this problem was quite meaningful to me because it taught me to, like, our first kick just started from the problem, so noticing that we have square root and square and recursion. And second one, we have like a fraction here, so that we might have to change our form like this. That was our third one. And noticing the pattern and telescoping it, and I think it's quite obvious from here. So I really loved learning about this problem, and if you also like this problem, please don't forget to share and like this video, and also subscribe for more videos like this. Then thank you so much for watching this video, and tomorrow I'll come back with another very fun and exciting problem. Thank you, and see you tomorrow. Bye.